Welcome to the complete eMobility and charging stations training session. As the world shifts towards a more sustainable future, electric vehicles are becoming increasingly popular. However, the success of eMobility relies heavily on the availability of charging infrastructure and enough knowledge of this new technology. In this video we will start with an overview of the eMobility ecosystem, defining electric vehicles and their types, and introduce electric vehicle supply equipment along with various technologies associated with it. We'll then delve into charging modes, levels, charging station types and charging connector types and standards. Stay tuned and let's get started. What is eMobility? The future of mobility is electric. eMobility or electric mobility refers to using electric vehicles to move from one place to another. Examples of these vehicles are e-bikes, e-motorcycles, electric cars and other forms of electric public transportation. eMobility ecosystem. The eMobility ecosystem consists of many players, and due to the different types of growth developments, there is an increasing interaction and overlap between these players. Here you can see an eMobility ecosystem and its different components and members. Let's have a look at the most critical components of the eMobility ecosystem. The first component of the eMobility network is electric vehicle or EV. An EV is defined as a vehicle that can be powered by an electric motor that draws electricity from a battery and is capable of being charged from an external source. There are two types of electric vehicle involved in eMobility: plug-in hybrid electric vehicle and all-electric vehicle. All-electric vehicles, also referred to as battery electric vehicle or BEV, has an electric motor instead of an internal combustion engine. The vehicle uses a large traction battery pack to power the electric motor and must be plugged into a wallbox charger or charging station. Because it runs on electricity, the vehicle emits no exhaust from a tailpipe and does not contain the typical liquid fuel components, such as a fuel pump, fuel line, or fuel tank. The other type of electric vehicle is called plug-in hybrid electric vehicle or PHEV. These EVs use batteries to power an electric motor and another fuel, such as gasoline, to power an internal combustion engine. PHEV batteries can be charged using a wall outlet or charging equipment, by the internal combustion engine, or through regenerative braking. The vehicle typically runs on electric power until the battery is nearly depleted, and then the car automatically switches over to use the internal combustion engine. We just discussed one of the eMobility ecosystem components, which usually comes together with its driver and is referred to as the EV driver. Now let's get back to the eMobility ecosystem. The next eMobility ecosystem player is the charge point operator or CPO. A charge point operator builds charging sites for electric vehicles, installs hardware from a variety of electric vehicle supply equipment vendors, and ensures charging operations are ongoing optimally. CPO provides the charging network infrastructure, managing the back-end technologies, as well as the communications between the back-end system and the chargers to deliver reliable and consistent electric vehicle charging experience. CPO customers are eMobility service providers, who own and manage the business relationships with electric vehicles drivers. Now you would ask, who is the eMobility service provider? The eMobility service provider or EMSP is a company offering the charging services to drivers of electric vehicles. EMSP delivers end-to-end EV charging, handling both charging station operations and the driver experience. To understand these charging services, imagine that you manage a fleet which includes electric vehicles, but your electric vehicles don't have access to a sufficiently large network of charging points. An eMobility service provider can support you by granting access to a huge number of charging stations around a certain area, for example, the city where your fleet is based and where the capacity is needed. If you decide to use the service of an eMobility service provider, you will be registered into the EMSPS system and your drivers can use the charging infrastructure via a charging card or app. The eMobility service provider will take care of the billing as well. The next actor in the eMobility ecosystem is energy supplier. The energy supplier is responsible for supplying power to the charging points and has strong ties with the distribution system operator and the transmission system operator to ensure that the energy is properly balanced. Fleet managers and lease companies. In the e-mobility ecosystem, these are the companies that often stand between the car manufacturers and end users and offer electric cars based on different business models. They sell and deliver cars to businesses and customers and often service them as well. Apart from fleet managers, there are municipalities and authorities. They care for the community for which they are responsible and accountable. They also manage public facilities such as parking, roads, and charging infrastructure. Authorities are also in charge of defining the related regulations and rules. Car manufacturers and automotive companies are the other important actors in the e-mobility ecosystem. They are companies that make, distribute, and market electric vehicles, such as car manufacturers and dealers. Electric, autonomous, and connected vehicles are disrupting the market at a breakneck pace, giving these players the opportunity to enter the e-mobility market. The last important component of the e-mobility network is the charge point, which is known as Electric Vehicle Supply Equipment, or EVSE. Electric Vehicle Supply Equipment supplies electricity to an electric vehicle. They are commonly called charging stations and are managed by the charge point operators and used by electric vehicle drivers to charge their vehicles. Charging station systems include the electrical conductors, related equipment, software, and communications protocols that deliver energy efficiently and safely to the vehicle. EVSE equipment is classified from many different technical perspectives, which we will discuss in detail in this video. The first aspect of distinguishing charging stations is their charging technologies. Different technologies are available for EV charging. Wired solutions using conductive methods are by far the most diffused, as they can easily guarantee the required power level, safety, and interoperability with most of the vehicles. Non-wired solutions are being studied for highway applications. Battery swapping is for special applications such as car races where rapidity is paramount. Alternating current or AC infrastructures rely on vehicles' onboard chargers and are limited in power level due to vehicle limited size and cost. However, direct current or DC infrastructures use off-board power electronics installed at the charging station. This allows for larger, bulkier, and more expensive components, meaning a charging power of up to 350 kilowatts in today's best-performing devices. Although in the first years of e-mobility development the trend was to improve AC charging power up to 43 kilowatts in some models, the present approach is to limit AC charging to less than 22 kilowatts or often 7 kilowatt single-phase and 11 kilowatt three-phase. Fast charging is performed by the DC chargers, which are becoming standard equipment for all EVs. We know the different charging technologies. It may now be better to understand what the difference between AC and DC charging is. The power coming from the electricity grid is always alternating current or AC. However, an electric car battery is able to accept only direct current or DC. The main difference between AC and DC charging, though, is the location where the AC power gets converted. It can be converted outside or inside the car. The DC chargers are usually bigger since the converter is inside the charging station. This means that it is faster than the AC chargers when it comes to charging the battery. By contrast, if you use AC charging, the converting process only starts inside of the car. Electric vehicles have a built-in AC-DC converter called an onboard charger that converts AC power to DC power. After converting the power, the car's battery is charged. Charging stations are also classified according to the charging modes. There are 4 modes of charging that differ from one to another by current type, voltage, and power delivery capability. We describe it from lower to higher charging speed. Mode 1. In charging mode 1, a domestic charging cable is used for the AC power supply of the EV. You simply plug one end of the charging cable into the wall socket and the other end into the electric car. Typically, Mode 1 is used for charging electric bikes and scooters. With this type of charging, there are no protective measures that allow control and communication with the electric car. As a result, the charging interface is immediately live and offers no electrical protection. The emergency charging cable thus provides little safety for the house, electric car, and person charging the electric car. In addition, Charging with the charging mode 1 is prohibited in many countries. The rated values for current and voltage shall not exceed 16 amps 250 volts AC in single phase and not 16 amps 480 volts AC in three-phase. EV supply equipment intended for Mode 1 charging shall provide a protective earthing conductor from the standard plug to the vehicle connector. Charging Mode 2. Unlike Charging Mode 1, Charging Mode 2 has means of communicating with the vehicle and provides protection against electric shocks. This ensures more safety for yourself, your home and your electric car. In Mode 2, the charging station is not hardwired to the building's power supply. This means that you can install the charging station yourself. It can also be easily removed from the wall mounting plate and used on the move. So if you want to take your charging station on a trip, that's no problem. It is portable and does not need to be installed by an electrician. You simply connect the charging cable to a domestic socket and charging starts. The rated values for current and voltage must not exceed 32 amps 250 volts AC in single phase, and 32 amps 480 volts AC in a three-phase installation, as defined in IEC 61851-1. EV supply equipment intended for Mode 2 charging shall provide a protective earthing conductor from the standard plug to the vehicle connector. Charging your EV in Mode 3. Charging Mode 3 is one of the most common charging modes for charging with alternating current or AC. Charging in Mode 3 works similarly to charging in Charging Mode 2, except that the wall box is hardwired to the building's power supply. Therefore, the Charging Mode 3 charging station is not mobile. The charging cable is either connected to such a charging station or you need to bring your own charging cable. In many countries, Mode 3 is the only mode allowed to charge the electric car in public areas in alternating current. Charging stations operating in Mode 3 usually allow charging up to 32 amps 250 volts in single phase, while from 11 to 63 amps 400 volts in three-phase. EV supply equipment intended for Mode 3 charging shall provide a protective earthing conductor to the EV socket inlet or its connector. While in charging modes 1 to 3 the alternating current is converted into direct current in the vehicle. In charging mode 4 the conversion from alternating current to direct current takes place in the charging station itself and not in the vehicle, so that the direct current is delivered directly to the vehicle. Charging Mode 4 is commonly known as direct current or DC charging. A charging station operating in Mode 4 charge requires an input voltage of 450 volts. DC charging stations are mostly located along motorways and exist only as stationary models. In Mode 2, 3 and 4 the addition of a control pilot inside the charging station enables communication between the vehicle and the charging equipment through standard protocols. It also allows the implementation of control functions, such as verification that the electric vehicle is correctly connected to the EV supply equipment, continuous verification of the integrity of the protective conductor, energization and de-energization of the power supply, transmission of information about the maximum permitted current to draw, charging plugs and connectors. Depending on the cable, charger, or the limitations of the vehicle's onboard charger, there are different types of connectors to plug the charging cable to the vehicle inlet. AC connectors are defined by IEC 62196-2. DC connectors are defined by IEC 62196-3, while other manufacturers have their own standards as well. Type 1 is known as SAE J1772 or JPlug. The 5-pin standard electric mobile connector common to most American and Asian electric vehicles. It is used by all EV manufacturers except Tesla. The Type 1 plug is used for charging an electric vehicle from charging complexes according to Mode 2 and Mode 3 standards. It can deliver between 3 and 7.4 kilowatts and supports only single phase with a maximum current of 32 amps. It's mainly used in the USA and Japan, but is also accepted in Europe. Type 2, known also as Menekes. The 7-pin charging connector Type 2 is used for the AC charging stations. This type of connector is approved as the European standard, as well as several Chinese cars that have been adapted. The connector stands out with a unique design. rounded but with a flat edge on the top. Its pin distribution is similar to Type 1, but includes 2 more pins, corresponding to the 2 extra phases needed for 3-phase charging. It allows charging in single phase up to 32 amps and 3 phases up to 63 amps. Chademo. The 2-pin DC connector was developed with the cooperation of major Japanese automakers with TEPCO. It can be used to charge most Japanese, American and several European electric vehicles. It is designed for use in powerful DC charging stations in mode 4 to charge up the battery to 80% in 30 minutes at a power of 50 kilowatts. It is designed for a maximum voltage of 500 volts and a current of 125 amps with a power of up to 63 kilowatts, but the revised Chademo 2.0 specification allows for up to 400 kilowatts. CCS Combo Type 1 and Type 2. These are a combined connector type that allows you to use both slow and fast charging points. The connector can be operated due to inverter technology that converts DC to AC. The CCS combo connectors are not the same for Europe and the US and Japan. For Europe, Combo 2 connector is based on the Type 2 or Menikes, and for the US and Japan, Combo 1 compatible with Type 1 or J1772. CCS Type 2 is currently the most common type of connector for DC fast charging stations in Europe. Both CCS1 and CCS2 allow DC charging up to 350 kilowatts when equipped with an active cooling system. Tesla Supercharger. World's biggest EV manufacturer uses its own type of charging connector called Tesla Supercharger. This plug type also differs for North America and Europe. Unless you own a Tesla Model S or Tesla Model X, then you would never need to know about this connector type. It has been one of the most innovative connector types in the past, combining both AC charging and DC charging into one socket and plug. For newer models like Model 3 and Model Y, CCS standards will be used. Therefore, it is likely that the Tesla connector type may be slowly phased out. We are at the end of this training session. Please subscribe to our channel and stay tuned for the later training videos.